Okay, so guys, listen. We're in section 2.13, and we're going to be in section 2.13 for 3 days. There's an A, a B, a C, a practice set 1, practice set 2, practice set 3. So I'll keep you organized with the page numbers. It's all solving equations, and then later, like the last day, a couple days from now, it's inequality. So we're doing a lot of solving equations, like solve for x, okay? Just higher level solving equations than the basic ones. Then we will do 2.14, then 2.15. So there's 3 sections left in Unit 2. That'll get us to next Tuesday will be our last new material. Then you'll have 2 review days for our quiz next Friday. We will have an in-class, old-fashioned paper and pencil quiz, not open note, in class that Friday. I made a review that's just like it. But it's just going to cover those 3 sections. That gets us to Unit 3, which is my favorite, trigonometry. And we'll work on Unit 3 until a little bit into quarter 4. And we'll have our last test that will go on whatever, don't worry about that. And then after Unit 3, we'll have at least 6 weeks to review for the AP exam. In fact, and I'm not going to give you all the details now, but Miss Springer, who's the AP Calculus ABBC teacher, Miss Bunday, who is the AP Statistics teacher, and me, the 3 math AP teachers, are going to offer you guys an in-school mock exam. If you want to have an idea, we already have it booked. We already reserved the school. It's on Good Friday. It's a day you don't have school. It's 4 hours long. It's not required, but the mock exam that we give you, like I'll be giving my kids your test, all the AP teachers, so there's a bunch of really smart math kids in the building that day. We give you a mock exam that models exactly what you will feel on the day of the exam. Taking a 4-hour math test ain't nothing to sneeze at. And I don't know if you guys have ever taken a 4-hour math test before. So we really, one of the highest indicators of success on the AP exam is doing mock exams. And I do like 3 mock exams with you, but the other 2 are spread out over days. Like we'll do an FRQ one day and another FRQ. It's just, spread out versus sitting there and feeling the feelings of the day. We also, all of us give you 100% on the test, no matter what you get. It goes in the grade book as 100%. So think about every test we take in here and you guys study and stress and we review. You get 100% on it just for showing up that day and taking it. Obviously, we know not everybody can come in on a Good Friday. You might have religious stuff you have to do. It's a day off of school, so you're not required to be here, so we can't require you to. So we do give you opportunities to make it up, so you have the same opportunity as your peers, but it's not the same because we can't do it in a 4-hour period like that. We feed you a ton of food. We get lots and lots of food and snacks and drinks and stuff, and we feed you to bribe you to come and all that stuff. But just keep that in mind. That's something that we do coming up like in April, whenever Good Friday is. So just give you that. All right. So what we're doing today is some review and some new stuff. All right. We're working with 2 basic types of equations, exponentials and logs. Let me start with exponentials. So in an exponential function, in an exponential equation, I should say, we have been already doing a type of problem. So this is a review of using the 1-to-1 property. I haven't called it that. You don't have to call it that. You're not going to have to memorize that. But what it means is this. When you have an exponential equation and the bases equal each other, right, they're the same, then you can set the exponents equal to each other. And so this is just a review of stuff we've already done. This is an exponential equation. How do I know? Because it doesn't say the word log in it, and it's got a base and an exponent. What you want to do is try to get like bases. So you want to see if you can change a 64 to a base 2, which you can. I mean, we know 2 squared is 4. 2 cubed is 8. You might even know 2 to the 4th power is 16. It's actually next to 1. Yes. Welcome back. Here, this is a worksheet we did yesterday as a review. You're welcome. But anyway, once you get to 2 to the 6th power, that would be 64. Okay? So remember, and we have already had problems like this. When your bases are the same or equal each other, then the exponents equal each other. Add 5, and we get 11. Okay? So solving an equation where the variable's in the exponent like that, you try to find like bases, okay? Let's do another one like that. This is an exponential equation. You have to recognize it, that that's that. And you think, ooh, I want like bases. But before you can get like bases, you have to get the base by itself. So 1/2 is the base here. If there's any other numbers hanging out on that side of the equation, you have to get rid of it. What would we do to get the 24 out of there? Divide. Right, so the 24's cancel. You're left with 1/2 to the power of x over 3. And when I simplify that, I would get 1/4. And you're like, wait, I need like bases. I need like bases. Well, I know how to make a 4 into a base 2. So let's do that. That would be 1/2 to the x over 3. Right? I'm not doing anything different over here. And I could make a 1/4 into a 1/2 to the power of what? What would I put the power as out here? 2. Think about it. Check it. 1 squared is 1. 2 squared is 4. So 1/2 to the second power is 1/4. We succeeded in getting like bases. So since the bases are the same, the exponents are the same. And to solve for x, we would multiply both sides by 3 and get x equals 6. Okay, so this is one type of problem that you'll have today. We've already learned it before. There's the review of it. Exponential functions. Let's talk about log functions. Log functions obviously have the word log in them. Okay, and applying the same one-to-one property to log equations is the same idea as over here. If you have a log base b equals u equals a log base b equals v, meaning the logs and their bases are equal to each other, then the u will equal the v. So look at an example. These are logs. There's a log on both sides, log on one side, log on the other, and they're both base what? What are the bases of those two logs? 10. Those are common logs. So we're going to be able to cancel them. But before we do, we have to apply the property of log called the power property. That's why we went over all those yesterday. When you see a number out in front, you can write it as an exponent. See a number out in front, you write it as an exponent. We have to do some cleanup to problems sometimes, like this one we had to divide by 24 before we could really start it. Same thing here. When you do x to the power of 1/2, remember, you can simplify that further to the square root of x. That's a really common one. Okay, x to the power of 1/2, that's where the 1 and the 2 go. So I have log square root of x equals log of 2 squared, which is 4. Yeah. And since log base 10 and log base 10 are the same, they cancel, just like the 2's canceled over here. Same idea. And then you just solve the rest of the equation. I'm solving for x. X is trapped under a square root, so doing the opposite of that would be squaring both sides, and we get x equals 16. Now, logs have something that you have to look out for. Let me back up. Exponential functions, x can be any number in the world. You can get a positive number, a negative number, you can get a fraction, it doesn't matter. Any real number. But logs have some domain restrictions. Let's remember that in a log, b has to be greater than 0, x has to be greater than 0. That's just code for positive, okay? Your b and your x have to be positive. You'll never see a negative number there. So when you are solving an equation, you have to check for something called extraneous solutions, which you've heard that term before. What an extraneous solution is a solution derived from the original equation correctly. Like we did everything right, but we're applying algebra to something that has a restricted domain. So you have to check to see if it doesn't fit. In other words, in this problem, there's an x right here. X has to be greater than 0. We don't know what x is. We just know it has to be greater than 0. We're not allowed to have a negative there. So as long as our answer that we got is greater than 0, then we're good. It's not extraneous. If for some reason I solved this and I got negative 16, and I already determined that x has to be a positive number, I would say no solution. So you could get a no solution, okay? Let's look at another one. Right? I see this is a log equation, and I have logs on both sides. Notice both logs have the same base of 3. That will always happen, by the way. I'm not going to give you one that's log base 3 on this side and log base 7 on that side. Okay? They're always going to be the same. So then you say, great, I can use that one-to-one property where I cancel them. But is there any cleanup I have to do first? And yeah, a lot of times on these problems, you have to apply that power property, okay, before you can cancel anything. So that would be x squared, right? And this would be log base 3 of 4 to the third power, and I'll put that in my calculator in a second. So now that I see that they both have the log base 3 on both sides, I can do this. 4 to the third power, I put it in my calculator, and I got 64. You guys with me? How do we solve for x? Square root it. Don't forget, when you take the square root of something, you get two solutions. We get 8, and we get negative 8. Understand, anytime you do an even number root, it doesn't have to be a 2, it could be a 4. You have one in your homework, that's a 4th root. To do a 4th root, you would get 2 solutions as well. 2, a 4, a 6, you always get a plus or minus. And let me remind you where that button is now, because that's the number one question I got today, is how do you do a 4th root on your calculator? Well, if you go into your math menu, number 5 has that X there. We want number 5, but you have to put the root on your screen first. So if I want a 4th root, I would do 4, then go to math, and then hit number 5, and it already knows to put that 4 into the X, okay? So when you get to that problem. All right, so let's go back up though and see, am I going to keep both of these answers? The answer is no. X has to be greater than 0. So negative 8 is extraneous. I would only keep the positive 8. Can't have a negative X value. Okay? Now, we're going to stay with logs for a second. We just saw, these are pretty simple, right? We have logs on both sides. These are my favorite types. These are the easiest ones. We've already done the other type, this one, when there's only one log. Notice the difference between this example and the one we just did. There's only one log in this problem. This is there any cleanup? Meaning, do I have to do anything? Is there something in front of the log or whatever? There's not. This is when we rewrite this equation in its other form. Guys, remember, you always start with your base. Power is on the other side, equals that. So that's 2 to the 5th power equals 4x. I like to put the x on the left-hand side, so I wrote it as 4x equals 2 to the 5th. It doesn't matter, okay? Either one is perfectly fine, but you'll see me doing this instead. I like my x's on the left-hand side, personally. And it will help you when we get to inequalities if you start getting in the habit of doing that. So you'll see me doing that a lot. All right, so 4x equals 2 to the 5th power is 32. Divide by 4, and you don't have to show that step of dividing by 4, and x equals 8. Now let's go back. Remember, logs have a domain restriction. 4x has to be greater than 0. 4x is greater than 0. So if I divide both sides by 4, it's still x has to be greater than 0. Is 8 good? Yes, it's greater than 0. So whatever's in here, set greater than 0, and that will give you your restriction, okay? Last log problem we have to do. Now, so far we had logs on both sides. Love that because they cancel. A log on one side, rewrite it in its other form. That's a review of something we already learned. And here's our last type of log, and that's when you have multiple logs on a side. Guess what? We want it to look like that. So we're going to combine them, condense them. That's why we went over all those properties yesterday. We should look at this and say, oh, we have a plus sign. I'm going to apply the product property. I'm going to make this a single log. So I write the word log one time, and then I would do x times x plus 15. Could you have skipped that step right there? 100%. Maybe you could have just known that you were going to distribute and gone right to this step, which would be stop me if you have a question. So all I did was apply the product property. You see addition, multiplication, right? Division is subtraction. Now it's just like this problem over here. This problem is just like this problem. I'm going to rewrite it in its other form. Base 10 to the power of 2 equals all of that. But I like to start with my x's. So I'm going to do x squared plus 15x equals 10 to the power of 2, right? And you don't see a base on a log, it's a 10, which of course is 100. And this is a quadratic, right? It's an x to the second, not an x to the first. So we have to factor it. That's why we did that factoring review yesterday. So I'm going to bring the 100 to the other side. And this is a chart problem, y'all. You can make the chart. You can do it in your head. Do whatever you want. Okay? But what you're looking for are the two numbers that multiply to get negative 100 and add to get 15. Those numbers, for time's sake, I picked up my calculator or whatever and I figured it out, are 20 times 5 and 20 and 5. Which one would I make negative? I feel like I'm going really fast. 5 would be negative. Way to get back into it, Zach. Right? That makes both of those happy. Since there's a 1 in front, we don't have to do the bring down the outside 2s, but we don't have to do all that. We can just go right to our factored answer of x plus 20, x minus 5, set them equal to 0 and solve, and get our two solutions. We have a solution of negative 20 and a solution of 5. Two solutions from a quadratic, right? Now, don't forget, because it's a log equation, we have to respect the restricted domain. So there's two logs, and both of them contain an x. So we have to respect, like they're a team. If one of them can't have an x, the other one can't. This is what I mean. So for this log, x has to be greater than 0, right? We know that. And for this one, x plus 15 has to be greater than 0. Subtract 15, x can be greater than negative 15. Okay, so let me draw you a number line real quick. You don't have to do this, just look. So for that first one, x had to be greater than 0. So for that one, all of our numbers can be anything greater than 0. For the other part of the problem, though, they'll allow all of these numbers, right? But since you can't, you have to respect both of them. Like this log's domain, remember this one? This log's domain is just these numbers. We cannot include any of these. So we really only care about the numbers that are greater than 0. It has to meet both of their restrictions. Does that make sense, guys? Okay, so an easy way to think of it is the bigger number. So 0 is bigger than negative 15, so we can only take any number that's greater than 0. Okay, so we'll get rid of the negative 20 and keep the 5. So negative 20 would be extraneous. You wouldn't put it on the answer line. That's a great multiple choice question. You'll have negative 20, you'll have 5 and negative 20. You know what I mean? You'll have all the options. So you have to know to get rid of those extraneous ones. All right, one last problem, then one problem on the calculator, and we're done. Okay, is this an exponential or a log? Exponential. You don't see the word log anywhere in it, or ln. LNs are logs. So you go, oh, I know, my teacher said, when I get one of those, I see if there's any cleanup. Nope, my base is by itself. I don't have to move anything other side. And then she said, find like bases. So 8 and 26. How do I get a like base? Well, you can't. And if you remember back when we took the last test, we did just this type. This was a review today. And I said, I'll never give you one, for now, that you can't get like bases. If I hand you an exponential function, you'll be able to get like bases. But now we're going to introduce the type where you can't get like bases. So you have to have another way of doing this. It's easy, okay? And by the way, this method I'm going to show you works for all of them. So if you get to a problem like this and you're like, oh my gosh, I hate fractions. Why does she keep giving me these dumb fractions? I don't get it. Negative x. You can always fall back on the method I'm about to show you. It's kind of like the quadratic formula of all quadratics. Remember, with quadratics, you could have solved this by factoring, but you also could have done quadratic formula. Why didn't your Algebra 1 teacher just teach you one method because it worked for all quadratics? Because the quadratic formula is long and annoying, okay? Same thing. You can use the method I'm about to teach you right now for any exponential function, but like bases is quicker, okay? So let me show you. I'm just going to rewrite this problem again so I have a little room. I tried to find like bases and I couldn't. Here's the really cool thing that I love about algebra and solving equations is that fact that you can do anything you want to an equation. I can multiply this side by 217 if I want to, right? I'm allowed to. I don't know why I would do it, but I can, as long as I do what? Do the other side. You can do anything you want. Think about all the things you do. You don't even think about it. You add, you subtract, you multiply, you divide, you square root, you cube root, you square things, you cube things. So here's what I'm going to do. Watch. I'm going to take my base 8 and put a log base 8 on the same side. So all I did here was I put in a log base 8, right? That's all I did. And I'm allowed to do that, and I'll tell you why I did it in a second, as long as I do it to this side. So I would have a log base 8 of 26. The reason I did log base 8 of 8 is because of this log property. Log base b of b, what does that equal? 1. So log base 8 of 8 cancels. It's 1. And that x minus 3 gets to come down to the front because that's the power property. Remember, if it's an exponent, you can write it in the front. So I have x minus 3 is now down on the ground, which is what I'm trying to solve for. Remember, the whole assignment today is x equals something. Every single answer you get is going to be x equals something. And we have log base 8 of 26. Now, stay with me. I want to get x by itself. What would my next step be? Add 3. So one of the ways you can write your answer is just this. That's called an exact answer, okay? This is called an exact answer. It's very similar to, like, it happens a lot in geometry where you were told to leave your answer in radical form or have an exact answer, or like the square root of 7, or put it in your calculator and get 2 point whatever, okay? So exact, approximate. This is the exact answer, log base 8 of 26 plus 3. But we also are going to find what it equals approximately. So we're going to put that in our calculator. To do a log that's not a base 10, remember the shortcut is math alpha math. 8, 26. Make sure you get out of the parentheses before you add 3. And then round correctly. That's your approximate. Okay? Now, last thing I have to tell you, and then I'm going to do 3 homework problems with you, the 3 problems that everyone asked for help on. So just stay with me. One more thing to tell you. If I said to you all, you can graduate right now if you got that right. You have to show correct work, but you don't have to go to any more classes. You get to graduate right now. How important would that be to you? Huge, right? Like, yeah, or you get $1 million, like big stakes. What if I said that was the case, but you still had to show work, and you didn't want to turn this in yet until you were sure it was right because the stakes are so big? What we can do is check it using our calculator. I feel like I haven't done a good job in making sure what you guys know about solving an equation by graphing. When we do the intersection of 2 equations, that's solving an equation. If you went into so if I gave you this equation, like a really basic equation, none of you need even a calculator for that. You guys all would know the answer is 3, right? You subtract 7. But if you put x plus 7 in your y1 and 10 in y2, and you graphed it, found the intersection, it would tell you 3. Intersection is an awesome and easy way to solve the hardest of hard equations, like this one. So let's do this. Clear your RAM, though. That is the key, and I will explain to you in a minute why it is so important for you to clear your RAM, okay? But let's just check this one using our intersection on our calculator. Everybody do it. So y1, y2, it doesn't matter which one you make y1 and y2. So 8 to the power of x minus 3, and y sub 2 is 26. Okay? You have to hit graph. Now, as long as you can see like the whole graph, which I pretty much can, or as long as I can see where it touches the x-axis, that's all that matters. I don't have to ever change my window on these for the most part. Watch. Go to your calc and go to intersection. Intersection is the only one of those that you don't have to do any extra work. It's the easiest one of your calcs. If you cleared your RAM, your cursor will always be placed in a really good spot to begin with. But if you didn't clear your RAM, it won't, because somebody's already messed with it, okay? So all you have to do is put them in there, graph them, go to your calc, intersect, hit enter from wherever it is. Hit enter again, hit enter again. You hit enter 3 times, it gives you your answer. And you can see that was the answer, 4.5 is it. Okay, so intersection is a great way to solve any equation. Any, logs, exponentials, anything you want, okay? Good skill to have. SAT, can you imagine? You didn't remember how to solve something? Use your intersection. All right, so that's it. Here's the homework. Please don't make us wait for you. Everybody write it down, and then I'm going to do 3 of these problems with you. It would behoove you, benefit you, to do them with me, or else you're going to have questions. I took 3 of the hardest ones and doing them with you. So Zach, just note that's your new your phone number thingy too, okay, for the future. Just keep it away. Okay, everybody have that written down? We're going to do these 3 problems together. I didn't, instead of wasting another set of notes, I just wrote. So starting with number 4, we're going to do 4, 8, and 19 together. So do these with me. Sorry, I squeezed it in there. 5 times 10 to the power of x. First thing you say is x, that's an exponential function. Is there any cleanup I have to do? And the answer is yes. I have to get this 5 out of there. So that's the first step. And I don't need to see that work. If you look at my key when I put it up, I don't show all these steps all the time, okay? Let's divide by 5. And then you say to yourself, can I get like bases? That's what you want to try to do first. But you can't make a 35 into a base 10. That's okay. We have a new method of solving these. I'm going to give both sides a log base 10, which is just your common log. Okay, that's how I know what base to use, because I want to cancel. So that's log, let me write it again. Log 10 to the x equals log 35. Can you put the little 10 in there if you want to? Sure. It's not wrong, but you're not going to see it written like that. That's why I'm not doing it. Okay? So now that we have log base 10 of 10, that cancels. The x comes to the front. And that's it. There's my exact answer, right? Log 35. But let's also find the approximated answer. That's a base 10, so you can just use your log button if you want to. If you use your math, alpha math, you have to put the 10 in there, which is fine. But you have a special button for that one. And you get 1.544. So exact, approximate. Okay. Go to number 8. Number 8 is a log equation. Not LOG, LN. They're both logs. I know that if there was logs on both sides, I would cancel. Don't have that. If there's only one log, I have to rewrite it in its other form. But before I do that, I have to get rid of this 5. I need the log by itself first. You have 2 choices. So listen. You can make this 5 to be a power here on the 2x. Or you can divide both sides by 5. You decide which one you want to do. You will get the same answer. How do I decide? Well, if I'm going to get a nice even number over here, meaning 20 is divisible by 5 to get 4, I'm not going to deal with a power. Why would I deal with 2x to the power of 5 or whatever? Okay, so I have natural log of 2x equals 4. And I'm going to rewrite it. Always start with your base. Power on the other side equals that. But remember, I like to start with my x, so I'm going to put that first. 2x equals, what's my base? E. Right? Solve for x. Keep in mind, that's all you're doing, guys. Solving an equation. Get x by itself. So x equals e to the 4th divided by 2. And let's approximate it as well. E to the 4th, that's above your natural log button. Be careful. Look at your screen. These are the moments where if you just watch me do it, like you understand, I know you guys all understand that I'm typing buttons on my calculator, but until you do it with your own little fingers, you might make mistakes. Here's what I'm getting at. E to the 4th, I have to move my cursor before I divide by 2. Otherwise, divided by 2 would be up in the exponent. So it's e to the 4th divided by 2, and that would be 27.299. Okay. And please just skip to number 19 with me, and then I'll leave you alone. Take a second and say, is it exponential or is it log? It's log. I have one log in the whole problem, right there, but there's some messiness. I've got to clean it up. That 3 and that 2 have to go to the other side, but I have to do it correctly. Anybody want to guess what we would do first? Say it again. No, and that's so listen, what if I gave you this equation? If I said, what would your first step be? Yeah, it is because it's right up against it. So you would subtract 3 first. Guys, when in doubt on what to do first, think about in a regular equation. Would I add or subtract first, or would I multiply or divide first? And you would subtract first, okay? So that's 2 natural log x equals 6. Again, you can either apply this 2 to the x as an exponent, but that's, in my opinion, harder than just dividing by 2. Now, so those steps right there were just the cleanup. We haven't solved the problem yet, right? We want x by itself. So we're going to do e to the 3rd equals x. I like to start with my x equals e to the 3rd. So that's my exact answer, right? Put it in your calculator to get your approximated answer. Oops. So I think I covered all the weird stuff, but of course I'll be around to help. And you guys can work together. I want to hear you working together. Not chit-chatting about other stuff. Yeah? Thank you for reading.
details or